Today we'll see how to write a program based on linear search. For that we'll use a small example to understand the basic concepts that are involved. So imagine that you have a friend called Kevin who learned with you in your lower primary classes. So now you really do not know where his house is, and here is the lane in which he was living. So we have 15 houses here numbered from 0 to 14, and your task here is to find where your friend Kevin actually is living. To help you with this, you have a robot there with you. So how do you get the assistance from the robot? So first we had to tell the robot the information about the houses that are here, and also that you are actually trying to find Kevin. Okay, so first you give some information to the robot. After that, robot does the search, and then finally robot comes back to you and tell what are the findings. Okay, so let's see these three basic steps in a bit more of detail. So first, what are the information that you give to the robot? You tell the robot that there are 15 houses in which you had to search, and then you tell their house numbers. You tell that there are house numbers from 0 to 14, and these are the locations. And then you tell the name of the person that you had to find is Kevin. Okay, so that is the information that you actually have to give to the robot. And the second step is that robot does the search. Okay, so there are different ways in which robot can actually do the search, but here in our program we are actually telling the robot to perform a linear search. Okay, so what is linear search? Linear search means it will start from house number 0. First the robot goes to house number 0 and he searches if your friend Kevin is there. Okay, if Kevin is not there in house number 0, he moves to house number 1. If Kevin is not in house number 1, the robot moves to house number 2. If not there, moves to house number 3, then to 4, 5, 6, 7, and so on. So the robot continues to search for Kevin from 0 to 14, and in case, say, if Kevin is found in house number 9, the robot stops the search there. Okay, so that is the searching part. So in linear search, the search is done systematically from one end to the other, and it continues the search as long as the item which is being searched is not received. Okay, and the search stops as and when we actually get the item, or here in this case the person that we are looking for. So that is the robot's search, and again here it is linear search. And after that, the robot actually has to report back the findings to you. The first question that you had to ask is, could you find Kevin in any of the houses? Okay, so the answer there could be yes or no. So if it is a no, then you needn't ask any further questions to the robot, because you have understood Kevin is not there in any of the houses. But if the answer is yes, if the robot tells that yes, Kevin is there in one of the houses, then the next question that you can ask is, if yes, which house is Kevin living in? To this, the answer could be anywhere between, the answer could be a number between 0 and 14. Okay, so here what you have to think is that, can you directly ask the robot which house is Kevin living in? So the robot has conducted the search and the robot has come back. Can we ask the robot which house is Kevin living in? So here, if you ask this question directly, there could be some problems. So imagine the situation where Kevin was not there in any of these 14 houses. So which house is Kevin living in? So that question is something which the robot will have trouble in answering back, because Kevin is actually not there in any of the houses. So what should I answer when someone asks me which house is Kevin living in? So this is something similar to say, you would have seen in movies where advocates ask an innocent person, did you actually stab him with your left hand or your right hand? So this person actually hasn't stabbed anyone, so telling left or right is not the appropriate way. So here, as we are writing the program, we don't want to confuse our robot. So the first thing that we ask robot is, could you actually find Kevin? If you have found it, which is the house? Okay, so that is the way that we generally approach this particular problem. So now okay, so what is the best case for the robot? So robot has actually started from 0th house and is continuing till the 14th house. So the best case for the robot is to actually find Kevin in house number 0. Okay, so then it has to just search in one house, and if it's the second or the worst case, what is it? It's the last house or not found. So when Kevin is not there, or if Kevin is found in the last house, actually the robot will have to go through 15 houses to reach that conclusion. So that is the worst case. So if Kevin is found in the first house, robot actually reports back to us very quickly. But if Kevin is there in the 14th house, or if Kevin is not there in any of the houses, actually the robot will be taking a lot of time to perform the search. Okay, so with that in mind, we'll actually see what is a linear search problem. So the problem usually is like this. So you have a given array, there is some data in an array, and you have to search the index of a search element in this data array. So an example would be, so if you have a data array, say with the numbers 12, 11, 34, 22, 56, 24 and 43, and you are actually asked to search for a particular element 22. Okay, so here the output would be 3, because you can see in the 0th position is 12. This is the first position, second position and third position. Okay, so actually we are asking the compiler to actually look for this particular element 22 in this data. Okay, and so what it does, it actually goes through each of these indexes. It just like the robot did, it starts from the first 0th index, looks if it is 22, no, so it moves to the next index 1, and what is the element there, 11, it's not equal to 22, so again go to the next index, which is 2, see if there is an element 22 there, no, so it again moves to the next index or next space, and there it found 22. Okay, so so the output there is that 3 is the element that you actually have to 3 is the position where we actually find the element 22. So in linear search, the idea of the algorithm is to iterate across the array from left to right, searching for a specified element. So here we have seen it didn't start from 6, or it didn't start from the middle, but actually the search started from the 0th position, or it moves from left to right. Okay, for a specified element, it's searching for 22. As soon as the algorithm finds the search element, it stops there. Okay, so this is a sample program where we can find an element using linear search. Actually we can divide this to 3 parts. The first part where we are giving the information to the computer, and then the place where the computer or the compiler is actually, our computer program is performing the linear search, and the last part is where we actually report the data back to the user. So this is the first part. So hash include, we have given a few variables here. The data size, how many houses, or how much data are we going to read. Data of 100, this is an array where we will be storing the data. Search element, this is the element that we need to search. Found flag, this variable will be set as 0, we'll be setting it to 1 if we are actually finding the element. Okay, so this is to answer the question. Found flag is a variable that we are using to answer the question, could you actually find the person, or could you actually find the number. Okay, so this variable is used to help us in finding that particular answer. And element position is equal to -1. As you know, in arrays we don't have a position called -1. So element position is actually meant to store the position in which the search element is found. If it is found, element position will be assigned a new value, or else it will remain as -1. Okay, so this is the first step in printf statement. This is the first step in actually getting the information from the user. So first we are asking, enter the total number of elements here, and then we are scanning the number of elements to a variable called data size. And in the next step, so in this for loop, we are actually entering all those informations from the user. So here we have given index equal to 0, and index is less than the data size, the number of elements, and index plus plus. And for each of those elements, we are asking, enter the element 1, enter the element 2, 3, 4, 5. So depending upon the size, you will be entering that information here. And then finally, the third question is, enter the element that has to be searched for. So just like we gave the name Kevin earlier, here you will be giving a particular number for which you will have to conduct the search. So this is the information getting part. Okay, and this part is actually linear search part is coming here. So here, as we said earlier, from the first house to the last house, we are going to search if the number that was given to us is present. Okay, so this particular loop is for hopping from the first index to the last index. See, you can see here index equal to 0, and it will continue till index, as long as index is less than data size, it will continue, and the value of index is actually getting incremented by 1. So in each of these steps, we are actually looking, we are trying to find if the search element is actually present in that particular position. So this is that comparison is if search element is equal to data of index. Okay, if that match is found, what do we do there? We change the found flag. Okay, found flag was initially 0, we are going to change that to 1, and we actually have found the position in which the element actually is kept. So we'll update the element position. It was -1 earlier, but now we will change it to index, and after that we'll break. Break means we'll go out of this particular for loop. Okay, because the search is over, so we'll break. Okay, so this if loop will be getting executed only if we are actually finding the searched element. Okay, if it doesn't find a searched element, the found flag will remain as 0 and element position will remain as -1. So this is the searching part, and finally this is the reporting part. So the first question that we asked is, did you actually find the particular element? So for that we are using if found flag. Okay, so if the element is found, what do we print? We print the position of the element is element search. I mean, if the position of the element Kevin is this house number. So okay, the position of the element, say in our example it could be 5, is 3. Okay, so this gets printed if the person is found, and if the person is not found, what do we say? The element Kevin was not found in the entered list, and we stop the problem. Okay, so I have written an example. I have written this code in VS Code. Let's try running it. Okay, so this is a program. So I'll just run this program. So here they are asking, first they are asking enter the total number of elements. So let me just give 5, and then they are asking for element 1. So let me give 12, 23, 34, 45 and 56. And which is the element that has been searched for? So let me give 34, and the answer is the position of the element is the element 34 is 2. So actually where is it stored? 0, 1, 2. So the answer is right. Okay, so we'll look for one more example. We can just clear it. We'll run it once more. Okay, so again enter the number of elements, it's 5. So element 1 is 12, then 23, 34, 45, 56. The element that has to be searched for, let me give it as 100. So the element 100 is not found in the entered list. Okay, so well, that's it. That's about the program. Okay, thank you.